This question, question 3, is similar to question 1 in many respects. You can use a very similar a line of attack. So here we're told that there are no positive integer solutions to x squared minus y squared equals 10. So what we do is the complete opposite. We assume that x and y are both positive integers, that there are solutions that are positive integers. And we also know the idea of difference of two squares, where x squared minus y squared is equal to the product of the difference and the sum, so x minus y multiplied by x plus y. We then look at the two scenarios, once where x is greater than y, and then secondly we will look at the opposite, where y is greater than x. Since x and also y are positive integers, then the sum of them is going to be a positive integer. Likewise, the difference between them is going to be a positive integer. So therefore the multiplication of those two positive integers is also going to be a positive integer. Now we are assuming there are positive integer solutions. We are assuming that x squared minus y squared can equal 10. Okay, i.e. that x plus y and x minus y could equal 10. I suppose that's the question. Okay. Now, just very quickly, if you have two integers multiplied together to make 10, well, two positive integers, you're going to have either the fact that 2 times 5 is equal to 10, or you're going to have 1 times 10 is equal to 10. So let's look at both those two scenarios. Let's look at the scenario that the sum of x plus y equals 5, and the difference of x plus y is equal to 2. And if we work through that in terms of simultaneous equations, we get x being 7, in which case x is equal to 3.5. Okay, which is not part of the integer set. It's not a whole number. Likewise, if we look at the other scenario where x plus y is equal to 10 and the difference between x plus y is equal to 1, if we again use simultaneous equations, we find that 2x equals 11, therefore x is equal to 5.5, which again is not an integer. So we've just effectively proven or shown that for two positive integer values, x and y, and if I'm assuming that they do exist and that they can go into x squared minus y squared equals 10, I actually find that I've just contradicted myself. Okay, this scenario is impossible. I can't have a situation where I state that x and y are integers and then find that the only scenarios give me values that aren't integers. Okay, so I've contradicted my statements. I've tried to say that there are positive integers and they do work to be x squared minus y squared equal to 10, and I've just contradicted myself. The second scenario of y being greater than x is a little easier, because we can say that we're assuming that x and y are both positive integers, so therefore the sum of them are going to be positive integers, but the subtraction of them, so x minus y, okay, now where y is greater than x, is going to be negative, okay, therefore it's not a positive integer. Okay, so straight away and it's certainly not going to equal 10. Okay, so therefore we can say that there's a contradiction straight away on that one. So when I assume that x and y are positive integers, where y is, the second one is greater than the first one, I get a contradiction, as well as the first scenario I gave through where x is greater than y. Since I have these contradictions in both scenarios of both assumptions, using the original contradictory assumption that there were positive integers, I must therefore state that there are no positive integer values. Okay, solutions that would actually fit the equation x squared minus y squared is equal to 10.